So what is Lorentz force? For any field, either it is a magnetic field or electric field, charge is common. The total force acting on this charge with velocity v when it is placed in electric field and magnetic field is called Lorentz force. So the definition is like this: the total force acting on a charge with velocity v by or in the presence of electric E and magnetic B fields is called Lorentz force. Means whenever a charge is there, it experiences the force of attraction and force of repulsion, nothing but the Coulombic force, and subsequently it can create a magnetic field. So the net force acting on a charge Q when it is moving with velocity v in both electric and magnetic fields is called Lorentz force. So we can write FL is equal to FE plus FB. What is FE equation? QE, because electrostatic force equation is QE. Next, what is FB? Q into V cross B. See here, the B is magnetic field, V is velocity of the charge. So if you took the common Q, E plus V cross B. This is the expression for Lorentz force. And we should check the vector notation of this Lorentz force and the dependence of the Lorentz force in the next part. So the expression F is equal to, or FL is equal to Q into E plus V cross B. You can write the brackets differently. So the Lorentz force depends upon E, V, B. This is the first point. Depends upon electric field vector, velocity and magnetic field. So where V is velocity, where B is magnetic field. V means velocity of the given charge. If velocity of the given charge and magnetic field are parallel or anti-parallel, then this part is going to be vanished. So what we can write, FB is equal to Q into V cross B. So we can write QVB sin theta if V and B are parallel or anti-parallel. Parallel means theta is equal to 0 degrees for parallel, like this. Anti-parallel means maybe in the same strength but in opposite direction, theta is becoming 180 degrees. In both the cases, this FB is going to vanish because theta is 0 or 180, sin 0 is 0, so 180 is 0. So what we can write, FB is going to vanish. So how we can relate this Q and V and B? It's a corkscrew law, Maxwell's corkscrew law. With that screw law, we can say the direction of electric field, direction of magnetic field, direction of the velocity vector of the line joints. And one more point we should understand in this explanation is the force on the negative charge is opposite with respect to the force on positive charge. Force on negative is opposite to the force on positive. We can write like this, opposite to each other. If electron is not moving, V is 0. If electron is at rest, V is equal to 0. If V is equal to 0, then also this magnetic field is all going to vanish. So here it leads to FB is equal to 0. This is very, very important point in this aspects and dependence of the Lorentz force. So how to demonstrate the relationship between this FVB? If you know the one removal of a screw, so we are applying the force on the top and we used to adjust the rotation like this. So in this case, the screw moves up by doing the circulations. So this is the direction of the applied force. This is the direction of the magnetic field. This is the direction of velocity. This V and B are separated by an angle. And we can visualize this concept with your fingers also like this. These three fingers should be stretched in a form of mutually perpendicular to each other. So anything like this, which is upward, which is field, and this is one more. These two are separated with an angle, or like this we can say like this. This is also very, very important. This is force, this is magnetic field, this is velocity. These two fingers are separated by an angle. So if the angle between them is 90, then we can expect the maximum force, because sine 90 is going to be 1, the maximum value of the sine. So this can visualize be like this. So this point is visualized by like this. So what is the dimensions of this one? So we know that magnetic force is equal to QVB. From this we can write B is equal to F by QV. What is V? Velocity. Because we should write all the things into fundamentals. So the B is equal to F by Q means charge only. What is V? Velocity is equal to displacement by time, or length by time. So we can write LT. So if this is the case, we can write like this. What are the unit? Can you please tell me? Newton second by Coulomb meter. But 1 Newton second by Coulomb meter is equal to 1 Tesla. Continue. So what is this Tesla? SI unit of magnetic field or magnetic field strength. SI unit of B is equal to Tesla. So after the death of Mr. great scientist Nikola Tesla, the SI unit of B was put Tesla. But Tesla is rather a large unit. So in case of large terms, it is better to use the small quantities to find the magnetic fields. So we can write 1 Gauss is equal to 10 to the power of minus 4 Tesla. So what about the Earth's magnetic field? What is the Earth's magnetic field? For every substance, there is a magnetic field inside. So there are different substances, diamagnetic substances, paramagnetic, ferromagnetic. These will be under the next part of the lesson when we compare to the magnetism classified into matter. Earth is also one of the best magnetic material, have a large size. So what is the strength of the Earth's magnetic field? It is almost equal to 3.6 into 10 to the power of minus 5 Tesla. This is the Earth's magnetic field strength. So this point is very, very important. So such like this, we can visualize the concept of force, field and velocity with this dimensions. So what is the dimensional formula of B? Dimensional formula of B. The equation for magnetic force is QVB. From this we can write B is equal to FB by QE, where F is the force, Q is the charge, V is the velocity. Now we are applying the dimensional symbols or dimensional formula of each and every physical quantity that are related with the magnetic field. FB, force. What is the dimensional formula of the force? M L T power minus 2. Mass into acceleration. Q, charge. I is equal to Q by T. Q is equal to IT. What is I? A, T is T. Velocity, length by time. L T power minus 1 here. The T power minus 1 if goes to this side into T. L get cancelled. So we can write M. This A goes up 1. A power minus 1. T and T also get cancelled. So therefore T power minus 2. If you wrote the dimensional formula in an order, we can get this is the dimensional formula of B. So in intermediate syllabus, dimensional formula of all physical quantities from first year to second year, it is better to know, which is useful to the competitive exams. Now we will tabulate the strengths of the magnetic field at different physical situations. So it is better to draw a table for this information. So the physical situation, and this is magnetic field. So what are the different physical situations? The magnetic field is in Tesla. So what are the different physical situations? We'll go from top to bottom, means the highest part to the lowest values. So the first one is surface of a neutron star. So on the surface of a neutron star, the magnetic field strength is 10 to the power of 8 Tesla. Which is better. Tesla is the unit, T is the symbol of the unit. So second one, a typical large field in laboratory. A typical large field which is placed in, which was located in a laboratory. Its magnetic field strength will be 1 Tesla, exactly 1 unit. So if you see the third example, near a small magnet. So near a small magnet, we can expect the magnetic field of 10 to the power of minus 2 Tesla. So fourth example, on the Earth's surface. So on the Earth's surface, the magnetic field strength value will be 10 to the power of minus 5 Tesla. So it is in the order. Just before this table, what is the total magnetic field of the Earth? 3.6 into 10 to the power of minus 5 Tesla. This 10 power 5 or this 10 power 2 minus 2 or 10 power 0, 1 or 10 power 8 is the order of these magnetic fields. One more example in this order is human nerve fiber. Human nerve fiber. Yeah, we know that human eye is made up of different fibers, and we have different fibers in our stomach, and whole the body contains number of fibers of small size. These are also can respond to the magnetic field. So what is the human nerve fibers magnetic field effective? 10 to the power of minus 10 in the order. The last example in this case is interstellar space. So the interstellar space, which is predictable or unpredictable, many scientists are doing the research in the space things. Okay, so the space physicists are there. So the interstellar space, we can expect the magnetic field of the order of 10 to the power of minus 12 Tesla. These are all the orders. So these are all the different physical situations, from neutron stars to interstellar space. In between we can expect the Earth also having the magnetic field strength. So this is the table which is useful to the information.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.